Okay, we are going through the topics related to signals. Okay, and yes, we're sitting outside for half an hour. Come on. Okay, so we are talking about signals, and yesterday I showed you the Sidra software as well, which you can use for any type of intersection. Okay, it's not only for signals. I discussed it for signals, but you can see the options related to roundabout and stop sign and these things as well. Anyways, moving on, we are moving to another thing related to signal, which is coordination. Okay, so coordination is done on the main roads when the intersections are very close to each other. So we coordinate the signals, meaning we design their timings together so that they can, the vehicles can move through the highway without any stoppage. Okay, so they keep on finding the green time whenever they reach an intersection. It can also be applied to parallel one-way streets. Okay. So if you have congested areas, downtown areas, I thought it was yours. I thought it was yours. Okay. So we can also apply it to, this coordination can be applied to parallel one-way streets, parallel one-way streets as well in congested areas, because those streets are very short. Okay, they're very short and narrow. Okay, so if there's a very long queue, it will affect all the other intersections as well. So in these shorter streets, we then do the coordination so that the queue is not long. Okay, and people don't have to stop again and again. Okay, how do we do the coordination? We have to prepare our time-space diagram. Okay, there's an online tool as well for time-space diagram. If the internet permits, I can show it to you as well. Okay, so in a time-space diagram, we have time on the x-axis, distance on the y-axis. Time meaning you will plot the clock time, obviously, starting from any 0 point. Okay, and that 0 point is called as a reference line. Okay, so time-space diagram, it starts from the 0 time, which is called as a reference line. Okay, and then we have the distance. Now this is which distance? The distance along the highway. Okay, so we are starting, if we are starting from the top, for example, then the top of the diagram shows the 0 or the first intersection of the highway. Okay, the top point on the distance diagram shows the first intersection of the highway, and then from there you continue. Okay, so here you can see the first intersection, the second intersection, and so on. Okay, wherever there is an intersection, you see a band here. Okay, this band is representing the width of the intersection. Okay, so this is the width of the first intersection, the second one, the third one, and so on. Okay, there. At each band, you can see the signal timing. Okay, this is when the signal is red, this is when it is green, then this is when it is red again, and so on and so forth. Okay, so you can see at each band when the signal becomes green and red and so on. Clear? Now, how do I prepare, or how do I do the coordination? First of all, you draw this diagram. Okay, time, distance, and on the distance axis, then you make these bands which are for each intersection according to their distance. Clear? Okay. Sure. Then now you start doing the coordination. Okay, what is the purpose of coordination again?
To prevent queue because near intersection
Continuous flow, right? Okay, so I want the driver who will start from here, when he reaches the other intersection, the signal should be what for him?
Green.
Green. Okay, so I need to time the start of green for the next intersection. With reference to the first one, I need to time the start of the green for the next intersection. So I need how much time the vehicle will take to go from here to here. Okay, how do I calculate this time? Distance over speed. Okay, so you need the speed of the vehicle. Okay, the speed, average speed at which it will go from here to here. Okay, and you need the distance between the two intersections. Distance you already know, right? You already know the distance. You already plotted. Okay, speed, obviously then you have to do some sort of traffic study to know the speed. Okay, so for example, that this distance is 450 feet plus the width of the intersection. 450 feet is between the two intersections, and then we have this small width as well. So total distance is this much, 450 plus this width. Okay, divided by the speed of the vehicle, they got time 12.3 seconds. So after the first intersection becomes after the first intersection becomes green, the next one should become green after 12.3 seconds. Okay, so from the reference line I go 12.3 seconds forward and make the next green. Got it? Okay, clear? Then you do the same thing for the next one. Now you see the distance is not the same, right? Distance, obviously road distance changes. Okay, so now you will take this distance, and what about the speed?
Speed same.
Speed same. That's why we are doing this, right? Speed should be the same. Okay, you have to take it same. Huh? That's why we are doing the coordination, right? So the flow is continuous. Okay, so speed same. So I use the same speed with this distance. Okay, distance upon speed gives me now how much? 28.6 seconds. So from the first green, now I will go forward 28.6 seconds and make the next green. Okay, like make the green for the next intersection. Clear? Okay. Yeah, bring coffee. Okay, next one. Now the next one, next one you see it was 53.2 seconds. Okay, so again you have from the first intersection, from the reference line, after 53.2 seconds you have the next one. Okay, now all these are calculated from the first one. See, all the values are calculated from the first one. Okay, so this is 12.3 seconds from the first one, 28.6 seconds after the first one, 53 seconds after the first one. Clear? Clear? So I am always taking the distance from the first intersection. All distances are taken from the first intersection. All times are calculated from the first green.
So for 28.6 it is 12.3.
Yeah,
Plus
included,
6.
right?
Yes.
It's included. 12.6 is included. Okay. Now, yes. You see here what was happening. If everything is calculated from the first point, you can see the values are increasing, right? Because the distance is increasing. Okay, this is only 450 feet. This is 450 feet plus 600. This is this plus this plus this. Okay, so distance is increasing. That means the time also increasing. Okay, but then what happened here? Now it is only 17 seconds. Okay, it was actually 77 seconds. The actual time from here to here was 77.7 seconds. Okay, the rule is whenever the offset, we call this offset, okay, these timings are called as offsets, okay, the time which you are calculating for the green time, this is called as offset. The rule is whenever the offset, the value of the offset goes more than the cycle length, okay, then you will subtract the cycle length and just put the remaining time. Okay, so cycle length here was 60 seconds. In this case, the cycle length is 60 seconds. Okay, 12 seconds is less than cycle length, no problem. Less than cycle length, no problem. 53, still less. Here it was 77.7, which is more than the cycle length. Okay, so 77.7 minus 60, the remaining is. Okay, clear?
What's the remaining?
This is the remaining time.
17 point.
We're just putting the remaining time now after subtracting the cycle length. Clear? Okay. Now why are we doing this? Because we are calculating the time of the first green. Okay, I am calculating the time for the first green. Okay, so first green should happen in the first cycle, right? First green means what? It will happen in the first cycle. Okay, so if you skip the whole cycle, if I put 77 seconds, I skip the whole cycle, right? In 77 seconds, there's 60 seconds of cycle. So how can you skip the entire cycle and give me the second green? You cannot do this. Okay, you have to give me the first green. Okay, the first green will end, then the red will come, and then the next green will come. Okay, so we are putting the time for the first green for all these. Okay, so the first green should be in the first cycle. So whenever the offset goes more than one cycle, we have to subtract the cycle length. So I have the time in the first cycle. Okay. Okay. What else? Now let's say you calculate an offset. Cycle length is 60 seconds. You calculate the offset and it comes out to be 100. Okay. Now you will do what? 100 minus 60. You get 40, right? You put 40 here. You will put the green after 40 seconds. Now let's say you got 130 seconds.
So it's still same. If
You will subtract one cycle length.
2 seconds.
It will be how much? 130 minus 60, how much? 70. It's still more than cycle length, right? You will subtract again.
So 10.
So now you get 10. Got it? Until the offset becomes less than cycle length, you will keep on subtracting the cycle length. Okay? Because until the offset is more than cycle length, it's not the first cycle, it's not the first green. It's the second or the third green. Okay? I'm trying to find out where is the first green. Okay, the first green is in the first cycle and the offset becomes less than cycle length. Clear? Okay? Okay. So you have the first green for all the intersections. Okay. After the first green, you will have yellow. After yellow, you will have red, and then you will have another green, and so on and so forth. Okay. So the rest will continue using fixed time. So green is, for example, 20 seconds. Yellow is 2 seconds. So after 2 seconds, 20 seconds green, 2 seconds yellow, then red. After red, there's a time for red, right? After that much time, again 20 seconds green, 2 seconds yellow, again red. Clear? So it will continue like this. So you don't have to calculate the time for all the entire timeline. You just calculate the first green. After the first green, the timing is fixed. Okay? After the first green, the timing is fixed. Whatever you calculated right here. Okay? So after first green will start here. After that, it's fixed. I don't need to calculate it. Okay? I already did it when I was designing the signal. Okay, clear?
Doctor, so
Yes.
we will stop subtracting the cycle length when the offset is equal.
Less than cycle length.
Less. Less or equal.
Equal, then it will be 0, right? Equal you will still subtract.
Okay.
Okay. equal, you will still subtract. If it is 0, 0 means what? You are back to the reference line. Still you can use. Okay, so if your offset was exactly 60 seconds, let's say, cycle length is also 60 seconds. You subtract the cycle length. 60 minus 60, you will get what? 0. So the first offset, the first green is at the reference line. Fine, no problem. Okay, clear?
Yes, clear.
So I was making the point that, so I know the first green starts after 12.3 seconds. Then whatever green time I have designed, I will give this much. Then whatever yellow time I've designed, I'll give this much. Then the red, according to my calculations and so on. Okay, so the rest of these things will continue. Okay. Now coming back to coordination. So the first car can leave during green, right? When the green starts, the first car can leave, right? The last car will leave when?
It is yellow.
End of yellow, right? So the first point of this progression, we call it the progression. Okay? This is the progression of vehicles, the movement of vehicles from the first signal, from the first intersection to the last one. So I know how to get the first point. First point is start of green. Then you start of green, start of green, start of green, just keep on going in the same line. Okay? The last point is what?
End of yellow.
End of yellow. Okay? But end of yellow here. On this line. Okay? End of yellow on the first intersection. Okay? So first point is start of green. Last point end of yellow. Okay? Clear? Do I know the slope of these lines? Tell me. Do I know the slope of these lines? Actually, they have shown it here. This is the last line. So this is the end of yellow, see? This was my intersection, right? Okay, so the first point is start of green. The last point is end of yellow. Okay, so I know the points to join. What about the slope? Do I know the slope of these lines? I know? No? We do? What is it?
Speed.
Speed, right? I knew the speed, that's why how calculate the offset, right? So now I know the slope. The slope should be equal to the speed you have used for these calculations. Okay? Clear? So you know the first point, you know the last point, you can just draw two lines using the same slope. You want to check it? Very good. Clear? Okay? The area between the two lines is called as bandwidth. Okay? The area between the two lines, these two lines, the first and the last, this is called the bandwidth. What is bandwidth? The total time available for your progression. Okay? The total time available for your progression. So whoever is coming in these 30 seconds, for this example, the bandwidth is how much? 30 seconds. So whoever comes in these 30 seconds, he will continue moving at a speed of, if somebody comes before this, he has to stop, right? And somebody comes after this, again he has to stop. So he will be away from the progression. Progression is in these 30 seconds. Okay? Clear? This progression, the first progression starts with the first signal, right? The first series will start in the first signal. So the first progression is in the 30 seconds from the first green, right? The next one will be when the signal becomes green again. Okay, so again, after this red, again 30 seconds of bandwidth. Then again yellow, red, and then again 30 seconds of progression. Clear? So every time the first signal becomes green, you have this much bandwidth for the progression of vehicles. Anybody comes before or after, he will stop. Clear? Okay. So the first line is called the reference line, 0 time. From this line onwards, you start calculating the offsets. The offsets will give you the first green, the time of the first green. Okay? Clear? Sure? No? Tell me your question. What's your question? No question? Still not sure?
Repeat.
Huh?
Repeat.
Repeat what? Repeat doctor. Okay, I repeated doctor.
The last part
Which last part?
about the bandwidth.
About the bandwidth?
Yeah.
Okay. The progression starts when the green starts. Okay. The first vehicle leaves the first intersection. This is the start of the progression. Okay. Any vehicle which comes after that, they will have green, right? So they will keep on moving. When is the last time when the vehicle will come and they are able to move? When is the last time? That is the yellow. Okay. Clear? So from here to here, this is what we call as bandwidth. Okay. Bandwidth is the time. If you come during this time, you will find the signal green. And you can continue with the progression. Okay. Clear? Okay. So if you didn't come in these 30 seconds, you come after 30 seconds, you will have what? Red. And before that, you will have red. Okay. So every time the first signal becomes green, this happens. Okay. So every time the first signal becomes green, you have a bandwidth of progression. Clear?
Coordinating.
This is coordinated.
Is possible for every intersection or for every road? Or
No, intersections should be close to each other. It should be close to each other, and the other streets should be minor. The crossing streets should be minor. When they are major streets, then you cannot. You are prioritizing, right? I am prioritizing this one, and what will happen to this direction?
That's it.
I don't care, right? So I don't care because these are minor streets. Okay, so this is done when you have series of intersections close to each other on a major street, and they are crossed on all intersections by minor streets. All of them are minor. When the first major street will come, you will break the coordination. Okay, so for example, I have this intersection which has a major street now. So coordination will be up till here. I will not coordinate this one. Got it? So main highway, close signals, okay, and crossing minor streets.
Sir, about offset,
Hmm.
give us red time also,
No,
like 30 seconds.
where is that? No, start of the green. Start of the green. Offset is the start of the green.
Okay, after 30 seconds, will
Green will start. Before that, obviously, that will be red, right?
Yeah.
Before that is red. What? Okay. Here you see one-way coordination. This is one-way coordination. Vehicles are moving in this direction. This coordination done for this direction. Southbound. Okay. In some cases, you can do two-way coordination as well. The example is given here. Okay. So in two-way coordination, what will happen? Vehicles are moving in both directions. The signals are coordinated in both directions. Okay. But the problem with two-way coordination is I cannot use this entire time. You can see here, I'm using the entire time, right? From green to end of yellow. I'm using the entire time. Okay. Two-way coordination, you see here. Am I using the full green? No. Okay. Same thing on the other side as well. It starts from here, start of green, but now I cannot go to the end of red. Okay, because I have to look after the other direction as well. Okay, so I have to make the green signals in a way that both directions are going simultaneously.
Or make a bridge.
Huh?
Or make a bridge.
Yes. You finish your senior or not? No? Do then bridge design and then the ministry will take you. No, seriously. Seriously. You said you will take that.
I
Many
take
people
structure.
go for bridge.
I take
Bridge is a structure or what is it?
No, I
I
take
said to I
structure building.
building. Who cares about building?
Everyone cares about.
No way.
This is a building.
What?
This is a building.
You see the condition of the building. Who needs building? Nobody needs building. Anybody can build buildings, okay? They have contractors for that. We need more people in bridges. You don't trust me, go ask Dr. Noah. Okay? Anyways, where was I? Okay, so in two-way coordination, the bandwidth is smaller. In two-way coordination, the bandwidth is smaller. In one-way coordination, you can use the full time of green and yellow. Two-way coordination, then you cannot use it, okay? Because you are trying to find out the common green time for both directions. Okay, so you have to do some adjustments here. Okay, bandwidth you covered, cycle length, speed. Okay, for coordinated signals, you can calculate its bandwidth efficiency. Okay, one thing which you have to keep in mind, for coordinated signals, the cycle length should be constant for all of them. All of them should have the same cycle length. We have 4 signals, the cycle length for all 4 of them it should be the same. Okay, otherwise it will not work. So based upon that concept, then we can calculate the bandwidth efficiency as well. What is bandwidth efficiency? The bandwidth, available bandwidth, okay, in which the first and the last vehicle move, okay, that time divided by the total cycle length. Okay, so cycle length is common. First signal has 60 seconds, so the last one also has 60 seconds. Okay, and the bandwidth also obviously is also common. So good coordination has a bandwidth efficiency between 40 to 55%. So around half of the cycle length, the signal is open for continuous movement, 40 to 50%. Right, half of the cycle length. Okay, so the vehicles are moving continuously through the intersections in almost half of the time available. Clear? Okay, I've already mentioned these things. Okay, this is an example. We have this main highway, okay, and then there are minor streets. Okay, all of them have, all these intersections have a width of how much? 40 feet. Okay, all of them have 40 feet width. Okay, and then the distance between them is given. Okay, so for calculating from here, it will be 40, so it will be 500 plus 40, then 500 plus 40 and so on. Okay, the speed of the vehicles on this highway is found to be 30 miles per hour. The cycle length is 60 seconds, and then we have a phase split of 60-40, meaning the main highway will have 60% of the cycle length, and the other highway will have 40%. That the minor street will have 40% of the cycle length. Okay. So first thing is I'll calculate the phase time. Okay. First thing is I will calculate, or we can start with the calculation of the offsets, because we know the speed, we know the distances. Okay. So tell me the offsets. So the first offset will be 500 plus 40, 540 divided by the speed is what? 30, right? I'll call it offset 1. You have to do the conversion as well. Okay, so it will be 540 divided by speed, which is 30 to 1.47. How much is it? 12.2. And the next one will be how much? Distance is same, right? So, how much? Same? Same? Distance, which distance is same? Distance between the two streets is same. Okay? All are taken up from the top. So it will double.
So it's
Okay.
12 plus. Can we just take 12 plus 6, 15?
Sorry, say again.
Can we take it 12.2 plus 15 over 7? So 12 plus 12.
12 plus 12, what?
12.2 plus 12.2.
12.2 plus 12.2, 24.4. This is what I did. Okay. Next one will be 540 plus 540 plus 340. Next one. Next. This is the last one. Hmm? 50 what? Did we reach the end? Okay, so we did not cross the cycle length in any of these instances. Okay, so we know the offsets, we know the when should the first green start. Now I need to know the bandwidth. Okay, I need to know the bandwidth. Now in bandwidth, then I need to plot the green time. For the green time, I know. When will the green time start? I will know. Now I want to know when the green time will end. When the green time will end and how much will be the time for the yellow. Okay, only then I can plot the other line. Okay, so for that I will use the data which is given in the question, which is about the phase split. Okay, and then we have, okay, the phase split is 60-40. Okay, so obviously the main highway will have 60%, the minus sheet will have 40%, right? Okay, so what is 60% of the cycle length? How much is this? $36 seconds. Okay, so 36 seconds the phase time for the major road. Okay, now phase time includes three things: green plus yellow plus all red. So this 36 seconds includes green, yellow and all red. Okay, now for yellow and all red we have equations. For yellow and all red we have equations. So this will give us yellow and all red. Okay. So this is 1 second for signal, perception reaction time. The speed we know, 30 miles per hour, right? The speed which we use for the offset,
Yes.
30 miles per hour. Standard deceleration rate, 11.2. Gradient not given, so I will just take it 0. Okay. It is given, we'll take somewhere. Okay. W is the width of the intersection. How much is that? 40 feet. Okay, L is the length of the vehicle, which is taken as 20 feet. Okay, so yes, the first two things are yellow. The first two terms are yellow, and this one is the red. Okay, the all red term is the all red term. Okay, so give me these terms separately.
2.34. Yeah.
Two. Okay, so 2.34 seconds of yellow. We are dealing with yellow right now, okay? So 2.34 seconds of yellow, and then we have the green. Yes, we need the all red as well, yes. Yes. Okay, so 2.34 and 2. So this will help me to calculate green time. Okay, so the total phase time is 36 seconds. Out of this 36, I don't know the green time, but I have found the yellow and all red, which is 2.34 plus 2. Okay, so the green is how much?
You have 1.66.
Okay, so what will happen? You will draw the first green 0 time. After that, it will remain green for how many seconds?
31.
31.66. After 31.66, you will have yellow. Yellow of how much? 2.34. Okay, so this will be the end of yellow. Okay, so you know after the first green time, the next signal becomes green after how many seconds? First offset?
12.2.
12.2. So 12.2, then again 31 point something seconds of green and 2.34 seconds of yellow. Then the next one will become green after how many seconds? 24.2, so 24.4. So again 31 point seconds of green, and then okay, so you get it now. Clear? Okay, so you draw it and then you will plot these two lines. The first line starting from the green, the last line starting from the end of red, like this. Okay, and you can then measure the bandwidth as well. Clear? Okay? Yes. Now in the question they are asking for.
Can you do a lecture for 1 point or 2 point in the board?
I think it's not. Reference line. 31.6.
6.
Okay. Then yellow. 2.34.
3, 4.
Then red. Okay. How much is this?
That is 2.
1.66 plus 2.34. 34. 34.
How do you calculate it?
Yellow plus 2. This 2 value.
36 minus this? Minus what?
2.
Hmm? You have the cycle length? You have the cycle length? Okay. Cycle length is how much? 60, right? Cycle length is 60. From 60, 31.66 seconds, green. 2.34 seconds, yellow. The remaining is what?
26, yes.
Okay. Remaining is red, right? For this guy. We are doing it for this direction, right? So for this guy, it is red. Yes, some of it is all red, I know. 2 seconds is all red. So somewhere here is all red as well. But I'm not plotting all red. I don't have the third dimension here, right? I'm plotting what? Red. So whatever is remaining is red. How much is that? 26. So this is 26. Okay, and after 26, the same thing will repeat again. 31.66 seconds green, and then 2 point something seconds yellow, and then again 26 seconds yellow, red, and so on. Okay, I'm telling you because of the next step. We did not discuss it.
It will be same, Victor.
Yeah, same cycle will continue.
I mean, same 2.34.
Yes, same signal, right?
Yeah.
Okay, Clear? So this is the first intersection. Now you go to the next intersection. Next intersection is 12.2 seconds, right? First green, 12.2 seconds. So I will go 500 feet down. Okay, I'll make the next intersection. Okay, next intersection. Starting is red. Starting is red. And the first green will happen. Okay, after how many seconds? 12.2 seconds. Okay, after 12.2 seconds, 31.60 seconds green, 2.34 yellow, and then again 26 seconds red, and so on. Clear? Okay, so this is how the diagram is plotted. Now, if you look at the diagram,
Picture for yellow car. It's 2.96.
2.96,
2.97.
2.97. Who gave me this value?
Conversion. The FTMI we have to mile per hour. We have to convert to feet per second.
No, it's already done, right? Show me the no, that is it. Yellow.
It's not in feet per second.
Ah, okay, yes.
And FTMI.
Yeah. Okay, in the equation which we use for the yellow time, there is no conversion. You have to do the conversion on your own. Okay. Anyways,
It's wrong.
it's wrong. See. So this is how much now, Father? 2.2.97.
2.97.
The other one, all right. Your friend gave us. How much is that?
$1.36.
Okay, so the green will be how much? 63. Huh? Ah, okay. 31.63 only? The difference is this much? Very good. Now, so any one of you does this in the exam, I'll cut some marks for the speed because you didn't convert the speed, and then you will come fighting with me that, see, doctor, answer is same. Huh? Okay, anyways, so this will remain the same. Okay, now if you look at this diagram, if you look at this diagram, you will just see the first green or maybe the second green if the cycle length was exceeded. Okay, you will just see one or two cycle lengths here. They did not continue till the end, right? Because this is one-way progression. This is only one-way progression. Okay, but when they are doing the two-way progression, you see they continue till the end. Okay, so these guys are coming from here, and the next progression will be by these guys. Okay, so what we do is you plot the entire thing. You plot the entire thing. Okay, green, yellow, then red, then green, then yellow, and all that for 2-3 cycles on all intersections. Okay, then you try to plot these two lines within the green. Within the green. Okay, the two lines are what? My bandwidth. The two lines are my bandwidth. For one-way progression, I can make it like this, from the green to the red. From the green to the yellow. Okay, but for two-way progression, now I have a problem because I cannot use the whole green. I have to go, these two lines should go side by side during the green. Okay, so this one is going like this and this one is going like this. Okay, and I have to make sure that all of them, or both of them, don't stop. They don't intersect at any red here. Okay, so you plot this entire thing. Okay, and then you have to So, and the first line is calculated, the first line is plotted using the offset, no problem, like we did, or like they have done. The first line is plotted like we know, okay? But the second line cannot go till yellow, okay? For the second line, now you will try to find a gap, okay, in which both lines can go, or both directions can go simultaneously, okay, without intersecting the red, without intersecting the red. Got it? Okay, so this is the second part of the question which they are saying. So the first part is just plot this and make the first line. If it is one-way progression, you can make the second line from the yellow, no problem. You have the whole green and yellow for your bandwidth. Okay, one-way progression done. But if it is two-way progression, then you have to complete the graph like this. And then you will see the gap in the graph in which both lines can continue together. Okay, and now remember this one is going down because this direction, and this one is going up because in the other direction. Okay, but the speed will remain the same. The slope will remain the same. Okay, clear? So the offsets will work, but they will not work till the yellow. Okay, they will not work till the yellow. Clear? Okay, so this is the second step which they have mentioned in the question. Yes. So I have this tool, I will show it next time, but we will not do it completely. Okay, there are a lot of options. I will just show you some of them, and that's it.